Precalculus Chapter 2.8, exercises 45 through 54. We're continuing this series on solving rational inequalities and other types of things, absolute value inequalities, radicals. And we're going to do the same technique we used as before. It was called finding a critical number or critical numbers. And critical numbers are where our x values, where an expression is equal to 0 or undefined. So in this case we have x cubed times quantity x minus 2 over quantity x plus 3 squared is less than 0. So what we're going to do to find critical numbers, we're going to set first a numerator equal to 0. So if we let x cubed times quantity x minus 2 equals 0, we know that x equals 0 is a critical number, and also x equals 2. And also the denominator. If we set our denominator equal to 0, in this case quantity x plus 3 squared, we know that x plus 3 is equal to 0, so x equals negative 3 is another critical number. And now we can set up a number line for a sign chart analysis to figure this out. So first, for the numerator, I'm going to say x cubed times quantity x minus 2 and draw out a number line for that numerator, and then also for quantity x plus 3 squared for the denominator. And then we mark on the number line the critical numbers, and we try to keep them in relation to each other. And so negative 3 is the lowest critical number, which I'm going to put here in the denominator chart. And then for the numerator we have x equals 0 and x equals 2. So those are the three critical numbers we're going to use to help us evaluate the situation here. So first, looking at the numerator, we see that where x equals 0, the numerator is 0, and likewise where x equals 2, the value of the numerator is 0. And now we're going to check the signs for other intervals at negative 3 also. Now for x being less than 0, what we're going to have is a negative, and a negative cubed can also be negative. So we'll have a negative times a negative, so to the left of x equals 0 we'll have a positive value there. Now between 0 and 2 we're going to have a positive times a negative, or negative, and greater than 2 we are going to have the value of that numerator be positive. Next, for the denominator, at x equals negative 3 the value of that denominator is 0, and everywhere else, since we have x plus 3 squared, we'll have a positive in the denominator. So positive everywhere else. So for our summary of the two number lines together, we're going to have first positive divided by positive, which is positive, and then positive divided by 0, which is undefined, and then positive divided by positive, which is positive, then 0 divided by positive, which is 0, then negative divided by positive, which is negative, then 0 divided by positive, which is 0, and then positive divided by positive, which is positive. And so the interval where we see less than 0 is here between x equals 0 and x equals 2. So we're going to make our summary statement. I'm going to just rewrite this: x squared times quantity x minus 2 over quantity x plus 3 squared is less than 0 on the interval from greater than 0 to less than 2. So that would be that problem worked out. Next, odd number problem 47. And here we have a polynomial term here, quadratic term, x squared, minus a rational fraction, rational expression. And so for this, we would like to before setting up our shop to analyze, we'd like to create a single fraction with a common denominator. Well, our common denominator is simply going to be x. And so we ask ourselves, if we take this x squared, what do we have to multiply by x squared to get our common denominator of x? What do we have to multiply the numerator likewise by? Also x. And then we subtract out 2 over x, and this is all going to be greater than 0. And so combining the fractions here, we're going to get x cubed minus 2 over x, and that's going to be greater than 0. So now, to find our critical numbers, we say x cubed minus 2 is equal to 0, and then we add 2, x cubed is equal to 2, and so x is equal to the cube root of 2. So that's one of our critical numbers. And then we have, for denominator, we're going to have x equals 0. That's our denominator, our critical number for the denominator. So next, we can set up our numerator as we'll have x cubed minus 2. That's going to be what we evaluate in the numerator. And then we have x in the denominator. And so for our numerator, we have cube root of 2, and also we have, really that's it. And then we have for the denominator 0. And so to the left of cube root of 2, we're going to have negative values. So negative, negative, negative. And to the right of cube root of 2, we're going to have positive. And for this x down here, we're going to have, at 0, we're going to have a value of 0. Okay, that's a 0 there. Cube root of 2. Okay, and to the left, we're going to have negative, and to the right, we're going to have positive. Positive, positive. And so for a summary, we're going to have negative divided by negative, which is positive. We'll have negative divided by 0, which is undefined. We'll have negative divided by positive, which is negative. We'll have 0 divided by positive, which is 0, and then finally positive divided by positive, which is positive. And we want to know where our inequality value is greater than 0. So we can make our summary statement here. X squared minus 2 over x is greater than 0 on the interval of, well, we're going to have negative infinity to 0, and not including 0 because we're undefined. And then also we have, starting at cube root of, let me see what that is, hang on a second, I think we need to have greater than, so that's going to be a parentheses rather, parentheses cube root of 2, comma infinity. And so this is going to be our solution set. Next on our problem, 49, again we have two separate fractions, and for these we'd like to get a single common denominator, and to get a common denominator we can multiply these two together, so we can have quantity x plus 1 times quantity x minus 3 be our denominator. So now rewriting the original fraction, we have first 1 over x plus 1, and what do we have to multiply this by to get our common denominator? We have to multiply by x minus 3 over x minus 3. And now for the second fraction we have 1 over x minus 3, and what do we have to multiply this by? Well, it's going to be x plus 1 over x plus 1, and all this is going to be less than or equal to 0. And so just summing, we're going to have x minus 3 plus x plus 1 all over our common denominator of quantity x plus 1, x minus 3, and all this is less than or equal to 0, and combining like terms, we're going to have 2x minus 2 over quantity x plus 1, quantity x times quantity x minus 3, and all this again is less than or equal to 0. So now we can find our critical numbers. First of all, we have for our numerator 2x minus 2 is equal to 0. So 2 times quantity x minus 1 is equal to 0. So x equals 1 is one of our critical numbers. And then we set our denominator, x plus 1 times quantity x minus 3 equals 0, and for this we have x plus 1 equals 0, and we have x minus 3 equals 0, so we have x equals negative 1 and x equals 3. So these are our three critical numbers, and lining those out for the numerator, we have for 2 x plus 2, and I'm just going to leave this in factored form. So this is our number line for this expression here above, and then below we have quantity x plus 1 times quantity x minus 3, and then we list our critical numbers in order, and the lowest one we see is -1, which is represented in the denominator, and then we see 1, which is from the numerator expression, and then 3 again from the denominator, and we know where x equals 1, the value of the numerator is 0, and to the left we are negative for these placed in intervals, and to the right we are positive. And for the numerator, we have our numerator equal to 0 at -1 and 0 at 3. And then to the left, we have a negative times a negative, which is positive. Between -1 and 3, say 0, we would have a negative times a positive. And then greater than 3, we would have a positive. So our summary is going to be negative divided by positive, or negative divided by 0, which is undefined, negative divided by negative, which is positive, 0 divided by 1, which is 0, positive divided by negative, which is negative, positive divided by 0, which is undefined, and finally positive divided by positive, which is positive. So what we have here is our answer is going to be, okay, I'm going to rewrite the summary form, 1 over x plus 1 plus 1 over x minus 3 is less than or equal to 0. So we look for this less than, and we see from we see its negative sign, so we'll say negative infinity up to x equals -1, and then that's going to be parentheses off. Write that a little more neatly if I could. And then also between 0 and for 0, I think 0 is included as part of the bargain because we have less than or equal to, so we can go ahead and bracket this 0 here, and then we comma 3. So really this should be it, except it's wrong because that's 1, 3. It's easy to mistranscribe. Yeah, it's a 0 at x equals 1, so we have bracket 1, comma 3. There we go. So that looks better. Okay. Next under problem, 51. This time we have quantity x plus 3 times the absolute value of x minus 1 is greater than or equal to 0. So to find our critical number here, we're going to set our critical numbers. We have quantity x plus 3 times absolute value of x minus 1 is equal to 0, and so x plus 3 is equal to 0, and x minus 1 is equal to 0, and so x equals -3 is a critical number, as is x equals 1. So we can use this number line I'm about to construct here, x plus 3 times absolute value of x minus 1. And here we have our number line, and on our number line we have our critical numbers -3 and 1. And so we just evaluate. If we have a number less than -3, we're going to have a negative times a positive, so we'll have negative, and at -3 we have a value of 0. Between -3 and 1, say we plug in 0, we'll have a positive times a positive. This absolute value of x minus 1 is always going to be positive where it exists, where it's not 0. So they're going to have positive here, and then at 1 our value is going to be 0, and then for greater than 1 we're going to have be positive there too. So what we have for greater than or equal to, we're going to have this value of x plus 3 times absolute value of x minus 1 is greater than or equal to 0. And where does that start out? Well, it looks like at -3, looks like we have the value of 0, and so we can just bracket -3 right here, and then we go all the way to, now we could go all the way to 1, but 1 is 0, so 1 is still a permissible input, and so we can just go all the way here to infinity. And so this will be our solution set, greater than or equal to -3 and less than infinity. Okay, and now we have problem 53. We have this rational expression here. We have quantity x minus 5 times the absolute value of quantity x minus 2 over the square root of quantity 2x minus 3. And so for our numerator, we can set that numerator equal to 0. So we have x minus 5 times quantity x minus 2, absolute value of quantity x minus 2 is equal to 0. So we have x equals 5, and also the value of where x is 2, because if we have x equals 2, this equation is a solution. So anyway, and next we have this, first of all, we have a general restriction here that because we have a radical, we have 2x minus 3. Now in the numerator we would say 2x minus 3 is greater than or equal to 0, but in the denominator we cannot even have it be 0, so we have to set this greater than. So we're going to have 2x is greater than 3, so x is greater than 3 halves. So we know x has to be greater than 3 halves. 3 halves is a boundary. I was going to say the lowest value, but it can't even be 3 over 2. So let's go ahead and set up our, well, we have to do one more thing. If we set this equal to also, if we say 2x minus 3 equals 0, then we have x is equal to 3 halves. So that's also not only our boundary, but it's also our critical number itself. So here in the numerator, I'm going to put the numerator as quantity x minus 5 times the absolute value of x minus 2, and so we have that piece of the number line for the numerator, and then the denominator we have the square root of quantity 2x minus 3, and so we place that value right here, and then outline our critical numbers. Well, based on the denominator we have 3 over 2, so I'm going to put 3 over 2 right here, and then we have for the numerator x equals 2, and we have x equals 5, and then we can evaluate everything here. Well, for the numerator, if we have a number less than 2, say 0, well, we would have this, we would have negative times a positive, because this absolute value expression is going to be positive except where we have a value of 0, so at x equals 2. So we're going to have a negative, negative, negative. To the right of 2, x minus 5 is still going to be negative. and at 5 the expression will have a value of 0, and then greater than 5 will have a positive times a positive. Now for the denominator does not exist, so I'm going to say so we have, let's see, so I was going to say it'll actually be 0 here, and to the left we would have a undefined, or let me write that as does not exist, and we have 0 right here, and then to the right we would have positive, and we'd have positive all the way here, really, positive, positive, and we're looking for greater than or equal to 0. Well, if for a summary we'll have negative divided by 0, which is undefined. We have negative divided by positive, which is negative. We have 0 divided by positive, which is 0. We have negative divided by positive, which is negative. We have 0 divided by positive, which is 0, and then we have positive divided by positive, which is positive. So for this, I'm just trying to see, if we have greater than or equal to 0, we'd be defined here. So I think we would have this x minus 5 times the absolute value of x minus 2 over, we have the square root of quantity 2x minus 3 is greater than or equal to 0 on, now the book has the interval of greater than or equal to 5, but I also think that at 2 we're qualified, because then we would have 0 over a number, and so I think we can go ahead and put 2 here just as a single number, because that's equal to 0, and then have a union, and then we have greater than or equal to 5 up to infinity, to less than infinity. And so I'm going to go ahead and check that in a calculator really quickly just to be sure, because I don't want to be telling mistruths if at all possible. Okay, so let me clear that one. Put in. Okay, we have, make sure I get this right, we have x minus 5, x minus 2. So we have x minus 5 times the absolute value of x minus 2 over the square root of quantity 2x minus 3, and then we graph and see where this one leads here. Now see, we have greater than or equal to 5, that's for sure, but let's check 2 also. See, at 2, okay, at x equals 2, the function is also defined, and this y6 is for another one for a previous video. So I think we're good on this. Okay, I caught an error from the book. Anyway, we have problem 54 also to have you consider. But that's all I have here in this video lesson today. I hope this has been helpful to you. Good luck, and thanks for viewing.